Today I will be showing you how to solve a system of equations with two variable expressions using both the substitution method and the elimination method. And at the end of this tutorial I'm also going to show you how to solve it using a graphing calculator. Now this problem right here we're going to solve using the substitution method because it would work best. The substitution method may sound like it's going to be a pain, but it's actually quite easy. All you're doing is taking a variable like y and you're going to isolate it. So whenever you have, in order to isolate, you must subtract x from both sides. So you'd have a problem like after you have this, you're going to take and add it into your second equation here, except you're going to replace for y. The reasoning behind this is that now that you know that y is equal to 1 minus x, you know that you can get rid of the y variable in this equation completely. With the y variable gone, you can go back and solve it. So then you can take and have it look like this. Now that it looks like this, you can go on to just distributing. And since you only have one variable, you do like you would in algebra, and you would just break it down. You would add like terms, so then you would get a 3 minus 2x is equal to 9. You would take and subtract your 3 from both sides to isolate the variable and its coefficient. And then finally you would divide for the finish. And then finally you would have your answer for x. Now with this answer, you can just, once again, substitute. You can substitute it back into one of the equations. I would definitely suggest it being the first one because the first one has no coefficients in it. So now you have negative 3 plus y is equal to 1. Add 3 to both sides. And now you have y equaling to 4. Now, because system of equations are a linear function, you can write down these as coordinates. So your final answer could look something like negative 3 and 4. Because you can go back and graph this if you'd like. The next problem that we'll be doing is 3x plus y is equal to 13. X plus 6y is equal to negative 7. Alright, once again you're going to look at the problem and you have to just keep it simple, because obviously you wouldn't take something like you'd obviously want to isolate a single coefficient in the equation. So let's go for x. Alright, so then you want to get your 6y on the other side over here. So then you just subtract 6y minus 6y. So now you have negative 7 minus 6y, and x is equal to that. You're then, of course, going to resubstitute it into the equation. Since you know that x is equal to that, you can substitute it into the other equation. So it looks like 3 negative 7 minus 6y is equal plus y is equal to 13. Now, once again, just like you did with the first one, it is just going through and just solving it like you normally would. It's very simple. You shouldn't have any problem doing this. So then you're going to take and have your negative 21 and your negative 18. Plus your other y. So then you're going to have negative you're going to have negative 17 y negative 21 minus that 17y is equal to 13. Once again, you just go through and solve it. You add 21 to both sides, so you will get 13 plus 21 is equal to 34. And 34 divided by negative 17 is negative 2. So now you know that y is equal to negative 2. Now you're just going to go back to your original equation here. You can either pick the one that has the 6y or the one that has this no coefficient whatsoever. Once again, I would suggest keeping this easier on yourself and just go with the one that has no coefficient. So now that you know that y is equal to negative 2, you just plug it into the other equation. So now you've got 3x plus negative 2 is equal to 13. Add to both sides. and x is equal to 5. And then once again, if necessary, you can take and put these into a coordinate format because this is a linear equation. So you would have 5, -2.